Okay, sorry Alex and Josh, I forgot to tape ahead of time, but we've just done example number 2 in the notes packet that one of you picked up. And what we decided was that to find the area between two curves, essentially speaking, we are integrating, same as we have been in the past, but this time integrating from an upper curve to a lower one, which just effectively means subtract. So here's my upper curve, here's my lower curve, and I subtracted them. That integral turns out quite lovely. Now for the rest of you, what I wanted you to see as I colored in here is that integrated vertically, which is what I just said that I did, meant essentially I integrated vertical section. Okay, so I was integrating vertical sections, which means effectively what we just did to calculate this 4.5 that we got right here. What we just did was we effectively calculated little rectangles like this. Does everybody see it? Okay, so now we're going to do the same exact question, and we're going to do it sideways. Now watch how the picture looks the same, the answer will come out the same, but I want to show you how an integral with respect to y would kind of play out. So I'm going to take this same exact, don't forget these roots over here, I'm going to need those eventually. I'm going to take this same exact question, I'm going to put it on a clean sheet of paper, and I want to show you how an integral between two curves with respect to y would play out. Can you live with that? All right, so the graphs are exactly the same. I still have my 2 minus x squared graph, which is going to look like that. I still have my negative x graph, which is going to look like that. They still intersect at exactly the same places, which is a 2 over here and a negative 1 over here. The difference is now I want to integrate horizontal strips. Now, one of the reasons I'm showing you this is because there are particular scenarios where a vertical strip is easier for you and a particular scenario where a horizontal strip is easier for you. In this case, a horizontal is harder. But I just want to show you what harder looks like. Okay? First things first, if you're going to be integrating with respect to y, the one you're going to integrate with respect to, I want all my equations in the original question to isolate the other letter. Okay? So first things first, this one's okay, I just have to divide out a negative. I've now isolated x. This one's going to be a little bit harder, but not terrible. When I add x squared and subtract y from both sides, and then square root, don't forget your plus minus, I need to call that graph, or this equation, x is equal to the positive negative square root of 2 minus y with a 2. Please. Where the positive part of that graph is this part, and the negative part of that graph is this part. In very much the same way a positive negative square root of red x's separates the top from the bottom, a positive negative square root of rad y's separates the right from the left. So far, everybody with me? Okay, now what's the bigger issue here? The bigger issue is, as I said before, when I'm calculating horizontal strips, my strips are going horizontally, where will my boundaries go? Vertically. So now I need to know this lower boundary will be a y value, and this upper boundary will be a y value. But more importantly, I've got two different graphs going on here. Can you all see how that's going to be a different set of far to the right and far to the left than this is? Meaning, this graph kind of has a break right here, where below that green dotted line, my red graph is on the right and my green graph is on the left. Above that dotted line, The positive square root is on the right. The negative square root is on the left. Can you see it? Okay, we're going to do this, and I'm going to show you how much harder it is if you didn't jump at the easier integral. Now, why is that relevant? Because I've chosen to do the harder one even though it wasn't the one that was given. How often do you think on the AP the harder one will be the one that is given? And if you just look for it and turn it around, it'll be easier for you to do the other one. Does that make sense? So what is it specifically that I'm looking for? When I draw these areas in, first and most importantly, my mind, I don't physically do this, but in my mind I start drawing lines, boom, 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 up and down, and then I start drawing lines, boom, 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 right and left. And I'm looking for, all the way across those pink lines, was the same graph on top and the same graph on the bottom. And for my verticals, the answer is yes. When I start drawing those horizontals and ask the same question, my answer is no. The easier method is going to be the place where your answer was yes. Or, if they were both no's, the place where the answer was fewer different highs than lows. So if you have 2 different breaks in the verticals and 3 different breaks in the horizontals, do the verticals. Does that make sense? Every time you have a different graph on top or a different graph on the right, it's a new integral. Are we clear on that? Okay, let's go ahead and do this with respect to y's now. Now again, this time I'm using these 2 equations. And in both of these equations, I've isolated my x, which means my integral will be with respect to y. The letters that I put into this integral will have y's in them. The boundaries, since my stripes are moving horizontal, my boundaries will move vertical. You're always going to have one of each. A stripe that moves horizontal has boundaries that move vertical. A stripe that moves vertical has boundaries that moves horizontal. So good? Other way to think about it, if you are integrating with respect to y, your boundaries will be y's. If you are integrating with respect to x, your boundaries will be x's. Any way you want to think about that is fine with me as long as you get it right. So we're going to go ahead and first find these values. Okay, I just skipped over the elementary algebra part of this, but we just deduced that the y values would be a boundary of -2 up to a boundary of +1 for my yellow horizontal stripes, followed by a second integral that has a boundary of +1 up to a boundary of +2 for my green horizontal stripes. Still with me? Okay, so here I go. I'm going to write this out. My first integral, I'm going to do the top first, is on the right, farther to the positive numbers. I have this positive radical 2 minus y, and I'm going to subtract from that the negative radical of 2 minus y with respect to y, and that one's going to go from a height of 1 to a height of 2, so 1 to 2. So you see where I'm getting that from? Then I'm going to add that area, which covers all this stuff. Poor choice of stripes, because those are vertical, but you get the right area. I'm going to add all that stuff to this area, which really is horizontal stripes, and has a height, sorry, I'm going down farther, and goes from a height of -2 all the way up to a height of 1. And that covers the positive square root of 2 minus y graph, that's the red one on the right, minus the negative y graph, that's the green one on the left. Okay, fair enough to say that this is a moderately harder integral. Okay, now just to make my point, I want you to type it into your calculator. Okay, guys, you're going to get to see this whole one. We're going to start this one. We did wrap up the last one on our calculator and deduce that it was indeed the same value of 4.5. I'm going to start this one with a graph. And hopefully you all remember from pre-calc that a y-squared graph is What does it look like? It's a horizontal parabola. Will I see the whole thing or just half? I'll just see half. Theoretically, well, actually, I think I'll see the whole thing. I take that back. I'll see the whole thing. If I were to isolate the y, square rooting both sides, I'd see a positive, negative rad x. So it is the whole thing. And so this graph is going to be basically your parabola going sideways, like this. And x minus 2 is a line with a slope of 1 that crosses the y-axis at negative 2. So it'll just go up 1 over 1, up 1 over 1, so that this is the value 2 comma 0. And it looks something like this. So basically where I got that graph from. Now they didn't give me boundaries here. All they said is they want the area bounded by the parabola, the line, and the x-axis. So they are looking for this area in here. The parabola, the line, and the x-axis. It's worth noting that you do have to read these things very carefully because it's not always the entire enclosed region. Sometimes they'll use the word first quadrant region bounded by. That would be the same picture. Does everybody see it? So they.
Isn't the bottom part also bounded by 3 lines and curves?
Oh, that's a good point, Zach. Does everybody understand what Zach just said? He said this is a different region bounded by the curve, the parabola, and the x-axis, so doesn't it also count? I'm going to say one or the other, but they would be separate answers. Because if I take them both, then I've kind of excluded the x-axis. But you're right, it would have 2 answers. Now, the issue with that, Zach, is I made up this question. So it's got a human flaw in it. Okay. Can we take off the, can I change this, the first quadrant region bounded by? Let me add that wording, and then it's a non-issue. So I'm going to put that in here, of the first quadrant, and now it's a non-issue. I am going back to that yellow region. The AP wouldn't make a mistake like that. They're far more detail-oriented than I have time to be. But in any event, let's talk about this. If I were to do vertical stripes, top is the parabola, bottom is the axis. Top is the parabola, bottom is the line. 2 integrals. See it? If I were to do horizontal stripes, one more. Right side is the line, left side is the parabola. Right side is the line, left side is the parabola. Which way do you want to go?
Horizontal.
I want to go horizontal. 1 integral, done. 1 and done is the way I want to be. So that means I want everything in respect to y. That means I want to isolate x's. I'm good to go there. And this one will be super, super easy to isolate. I'll call that x equals y plus 2. So basically I got that. So first and most importantly, the picture is going to help you make your determination. If you want to go horizontal, you're looking for x equals equations. Your stripes will be horizontal. Your boundaries will be the y values going vertical. And that's what I'm going to have this time. So that means I need a lower boundary. That one's going to be pretty easy. What's my lower boundary going to be? 0. It's this y value right here. And I'm going to need an upper boundary, which means effectively, and that's not a 0, which means effectively I need to know the y value of this point. And I was going to try and circle that point. That's what I'm looking for next. Would you please try and find me the y value of the intersection between the positive square root of x and the line x minus 2. Now I think we're ready to put together our integral. And again, when I'm doing these horizontal stripes, my integral is going to go from bottom, that's this value, to top, that's this value. And then my functions are going to be the function that's farther to the right, the function that is more in the positive territory, the function that is where I'm going to find the bigger numbers visually. And sometimes this is super counterintuitive because you all think of a line as being smaller than a parabola. Well, degrees-wise it is, but in terms of value-wise it's not. So the line is going to come first. I called this a y plus 2. The parabola is going to come second. In this case, I'm going to stick to the positive square root because it's the one that's above. So I'm going to subtract from that the square root of, not x. I want a y squared. I had it the first time. And then that's going to be dy. Would you please calculate the value of that integral for me? And I've just done the calculation